Hi, everybody. Welcome to section 5.3, discussing the definite integral. So the learning objectives for this section will be to use the fundamental theorem of calculus to evaluate definite integrals and interpret the meaning of a definite integral using the concept of accumulation. So in developing the idea of the definite integral, let's consider this following applied problem. So before we get to any mathematical theorems, let's look at this example here where it might be easier to see. So a company claims that it can extract a certain n gallons of contaminated water per day from a deep well at the rate modeled by. So the keyword here is rate, meaning that it's a derivative, a keyword rate. So n of t equals 6t to the fourth minus 720t cubed plus 21,600t squared. And t is the number of days since the extraction began. How many gallons can the company extract in the first 10 days of operation? So the first 10 days of operation, what that means to me is when you're starting, that's when t equals 0, time equals 0. To the 10 days, that'll be t equals 10. So we need to accumulate how many gallons were extracted in the first 10 days. So since this function here, is a rate, so what we need to do is integrate. So for letter A, let's go ahead and write that down. Need to, I need to integrate from t equals 0 to t equals 10. And how do I do that? Well, let's go ahead and set up the integral first of all. So we'll have the integral 6t to the fourth minus 720t cubed plus 21,600t squared, and it will be a differential of dt. But how do I integrate from 0 to 10? So this is the concept of having limits or endpoints 0 and 10. And the way you would write this is 0 and 10 on our integral. So I need to integrate from 0 to 10. We're going to take the integral of this function as we normally would. So let's go ahead and do that. So this becomes 6t. I'm going to jump ahead without the plus ones. Hopefully we're a little familiar with that by now. T to the fifth over 5 minus 720 t to the fourth over 4 plus 21,600 t cubed over 3. And here we're not going to have a plus c. We're not going to have a plus c because we are integrating between two endpoints. We're accumulating. So the way you would write this is from t equals 0 to t equals 10. Okay, so let me go ahead and keep simplifying. So this becomes 6/5 t to the fifth. 720 divided by 4 is 180. T to the fourth. 21,600 divided by 3 is 720 or 7,200 t cubed. And once again, this is from t equals 10 to t equals 0. And so what do we do with these endpoints? What we're going to do is plug them separately into the integration we just found. So what do I mean by that is I'm going to have two different evaluations. So in this first bracket here, I'm going to plug in 10 to this function. So it'll be 6 fifths, 10 to the fifth, minus 180, 10 to the fourth, plus 7,200, 10 cubed. So that's me plugging in 10. Now I also want to plug in 0. We'll do the same exact thing, process, but here, just keep in mind we're going to subtract these two brackets. So this would be 6 fifths, 0 to the fifth, minus 180, 0 to the fourth, plus 7,200, 0 cubed, and close that off. This is us accumulating the number of gallons that we're extracting from 0 to 10. So we go ahead and simplify this. So I'll leave you to the calculations for this expression here. But what you should end up with is 5,520,000 in this first bracket here, minus, well, what's this minus? Well, this is 0. This is 0, and this is 0. So this is really minus 0. So our final answer is 5,520,000. So that's how we accumulate given a rate of gallons that we extracted. So I could write that out in the statement. So a total of 5,520,000 gallons are extracted during the first 10 days of operation. Okay, so that's us taking a rate and getting an actual input output. So I'm going to skip B. It'll just be the same type of process anyways, but that leads us into the fundamental theorem of calculus. So moving on to the next page, the fundamental theorem of calculus is where if f of x is a continuous function on an interval a to b, where a is less than b, and if capital F of x is the antiderivative of f of x, then the definite integral, we previously learned the indefinite integral, but the definite integral of f of x from a to b is basically what this states here. F of x, the integration of that from a to b is the integral, the antiderivative from a to b, and you're evaluating them independently and subtracting them. So this represents the total amount accumulated. That's that key word, accumulated. That's what we were doing in the previous problem by the capital F of x, which is the antiderivative. As x increases from a to b, the number a is called the lower limit of integration, and the number b is called the upper limit of integration. So that's basically what we did in this first problem. We integrated, 0 was our lower limit, 10 was our upper limit, integrated the function got our antiderivative, and we plugged in our upper and lower limits, subtracted them, and came up with a numerical answer. And notice that there was no plus c. Okay, so that's the fundamental theorem of calculus. We are accumulating over an interval. So that's it for this video. In the next one, we'll try out some examples in example one. But see you next time. Thank you.